Hi, folks. I'm Adrian Sanabria, the host of Enterprise Security Weekly. Every week, we interview the most interesting folks we can find, talking about the most pressing cybersecurity issues and challenges facing the enterprise today. Myself and my co-hosts have each been in the industry for decades, long enough to see the patterns in the industry and explore where trends are going. In addition to enterprise challenges, we also follow the vendor space, the most interesting security startups emerging, technology and product trends, all of the most interesting funding and acquisition announcements. Finally, we love to discuss the latest trends in tech and how they'll impact cybersecurity. If you're wondering how the latest in AI, quantum computing, cloud, and DevOps is going to impact security a few years down the road, you should follow the Enterprise Security Weekly podcast.
Hey everyone, welcome to today's interview segment. I'm, of course, your host, Paul Asadorian. I am joined by my good friend, Mr. Aaron Leland. Aaron, welcome.
Hi, Paul. Thanks for having me. Good to see you on this wondrous autumnal or whatever you guys call it, fall week.
Yes, it's good to be here. Aaron, I don't know if you have a programming like IDE of choice. It's interesting. I evaluated like a bunch of different IDEs when I was doing the heavy lifting with our PPWorks product in Python, and I landed on I like the JetBrains products, and Visual Code Studio, of course, is probably a little more popular, probably a little more the de facto standard, but we always worry about vulnerabilities inside of our tools, whether we're developers or security researchers. And we've seen trends where attackers will attempt to exploit and or backdoor various tools used by security researchers and developers alike. So the research that we're going to cover today, provided I remember to mute my phone, which I have not, I apologize. The research we're going to cover today are some vulnerabilities that were discovered in Microsoft's Visual Code Studio IDE. And I'll turn it over to our guests for this interview segment. I've done a lot of research on it. They work for a company called Sonar. So Thomas and Paul, welcome to the show.
Hello, thank you for having us.
Hello.
Yeah, and Thomas and Paul, if you wouldn't mind just separately introducing yourselves and giving us a little bit about your background. Thomas, why don't you go first?
Yeah, so my name is Thomas. I'm from France. I've been working with Sonar for 2 years now. I used to be doing offensive research and pen tests with Synactive, which is a well-known French company now. And I joined Sonar 2 years ago to try to build stronger defenses against vulnerabilities. So we have a product that just helps. It's like a spell checker, but for code, to just improve quality and security. I've been looking at a lot of open source projects these days, trying to find new critical vulnerabilities that we later disclose to the vendors. So it's offensive security, but we really help to increase the security of the ecosystem at the same time.
Nice. And Paul?
I'm Paul. I joined on the same day as Thomas, so we were both at Sonar for roughly 2.5 years. I'm also a vulnerability researcher there, and before that I was a developer and then studied cybersecurity and got into the practical field of it by playing hacker CTF competitions, and now I'm here.
That's awesome. Yeah, it seems to be a common theme. Someone we interviewed recently too said they got their start doing capture the flag exercises. So Thomas and Paul, did you guys know each other before you joined Sonar?
No, I don't think so. Maybe by name, maybe through CTFs, but no direct connection as far as I know.
Yeah, but we definitely played both in the Hackaset CTF, I think, before we joined, which is sponsored by the US Air Force. You have to hack some satellites, and actually this year's edition was on a real satellite on orbit. And I think the first edition we both played it, and then later we joined Sonar.
Yeah, different teams.
Gotcha. Yeah, different now, but you guys now have been on the same team for a while. So what kinds of things did you, like when you first joined, what kinds of things did you start working on and talking about researching?
So for me, I think the first project I took was Rocket Chat, which is the open source version of Slack, let's say. It was pretty cool, and I directly found something nice. No SQL injection that you could, not two to be exact, one that you could use pre-authenticated to get access, and then one to elevate your privileges. So that was a pretty cool first start, and already the vulnerability and how to exploit it was pretty close to some challenges we have in the CTF world, because it was a blind injection, so you have to have an oracle and gradually leak a secret value and stuff like this. So it was a fun start.
Awesome.
Yeah, and on my side, I was used to do like more research on kind of enterprisey software, like these big VPN appliances and all this stuff. And when I joined, was like we really tried to audit open source software, like Paul mentioned with Rocket Chat. And I was like, okay, maybe I could look into some developer tools. And I started looking into supply chain issues. And like in the PHP world, when you install dependencies, you use something that's called Composer. It's like a PHP package manager. And but when you install package, you only give the name, and you tell server, can you give me like the URL for this dependency with name, I don't know, Symfony, and the server replies and tells you, okay, you can go to GitHub and you can just fetch it from here. And I found a pretty cool remote code execution bug on this server. So basically, that means we could have kind of poisoned 2 billion dependency downloads per month. So it was like pretty huge, probably the most impactful thing I'm gonna ever find in my career. And that was my really first publication with Sonar. It was really cool to like do security, but like also try to improve the state of security for developers in general.
Now, Paul, you mentioned the Rocket Chat. Is that also an Electron application?
Yeah, so the server side is not, it's only Node.js, but I think they have a desktop client that's based on Electron.
Yeah. That seems to be, at some point, there was like a turning point where open source software and companies produced desktop clients written in Electron. And I was like, wow, that's security-wise sounds like a really bad idea to put JavaScript on people's desktops. And I think largely that's been the case. We've seen a lot of problems with Electron apps. Is that true from your perspective?
Yeah, I think definitely there's stuff in Electron. I think, yeah, one of the main things is that the front end part that you know from the web, you can have cross-site scripting. So basically, there is a way for people to, an easier than memory corruption way to execute some code on other people's machines if they find a cross-site scripting vulnerability. And then Electron, depending on how the application is configured, allows you to do more stuff. So I think in general, you could say that there's more things that have to be secured in an Electron app than maybe in other frameworks.
Yeah, Tomas, have you looked at Visual Studio Code that's also Electron, is that correct?
Yeah.
Is that was that easier pickings? I like how you said, cross-site scripting and remote code execution in the same sentence, because especially on the desktop client, cross-site scripting is kind of like remote code execution, right?
I mean,
it's been part of the research, and there are like many different layers to prevent you from like just leveraging your common XSS in RC. But we found some ways to sometimes get around these protection layers. But in theory, it's not badly designed. Like they have like really a strong separation between everything you can do in the app, and if you get an XSS in the like Markdown rendering, you do not directly get RC. Some people still did it, but they patched some of the steps they used to exploit it. It got honestly better. I would still think that like Microsoft has some more resources to do good security compared to many other companies, and even Microsoft failed a few times. So I would not recommend it to like smaller companies.
Right. When you approach finding vulnerabilities in a specific application, I've talked with a lot of security researchers over the years, and some are just like, hey, I just go look at the source code. Others are like, I look at the runtime and do debugging. And then, others are like, I use more fuzzers and automated tools. What's your approach when you start to evaluate the security of any given application?
So I guess the first thing that we do, being Sonar people, we use our own product. So it's a static analysis tool, so we can scan the code of the application. That's also why we mainly look at open source projects in our job. And if the application finds something, which oftentimes happens, but of course, static analysis can't find everything, then we look at those issues. And sometimes it's not a direct issue, but something that our product highlights that might be a security issue. And then a human like me has to look into it more and determine if it's actually a problem. And oftentimes that's the entry to the code base. And then it's, basically you have something that you start at. And even if it's not a vulnerability in itself, then you can look from there and explore the source code of the project and the functionalities.
Yeah, and I like that approach because I like to, encourage folks to do this work, and I think sometimes they can feel overwhelmed, like, oh my God, I'm gonna go try and find a security bug in this application, and it's 10,000, 20,000, 100,000 or more lines of code. Where do I begin? Do I just start looking at the source code starting with line 1? I think for the most part, you rely on some sort of tool or scripts that you've developed to hone in on where you should start looking, right? And that's kind of sounds like the way you're using Sonar and maybe some other tools as well.
And with experience, you also get used to, it's it's an IDE, so I know this the common attack surfaces for IDEs, and this is a web app like a CMS, and I already owned a few CMS, so I can already maybe reuse some of my previous techniques and just ideas on this new one. It's always easier to already make some scenarios in your mind before approaching the target, so you already start digging in the right attack surface, in the right things. You don't have to read every single line one by one. I mean, in the case of VSCode, it's close to 1 million line of code. I forgot the exact number. Paul, I think you have it in your mind.
I think 800,000.
Yeah, it's just crazy.
It was around 800,000 lines of code. Yeah. And of course, counting lines of code is, there's some variance there, obviously, when you count lines of code. But as a rough estimate, that's a pretty large project in my mind. So, tell us a little bit about the bugs that that you discovered early on looking at the VS Code.
Yeah, I think so. One of them is basically in the Git integration of Visual Studio Code. So of course, almost everybody uses Git who develops, especially in teams, and you want a nice integration into your IDE. You want to know what commit you're on, what branch, maybe who committed to this line of code. And because Git in itself is quite a complex piece of software handling different things like diffing, commits, merging, and everything like this, you don't really want to re-implement it, especially probably not in TypeScript. So what VS Code does and what a lot of other IDEs and software does is that they just call the Git command line utility with arguments and then pass the output and do their stuff this way. So what VS Code did in some versions is that when you open a project in VS Code, it would run, for example, the git status command to see if there are changed files, unchanged files, and so on. And the thing about Git is that you can configure it in multiple ways. So you have a global config, then you can have a per user config, and also a per project config. So in every whenever you clone a Git project somewhere, then you will have a .git folder in that cloned folder, and that's where Git keeps all its files to manage everything, including a config file. And in this config file, you can override certain things that can, basically execute arbitrary code in certain conditions. So in a normal, non-malicious way, you might want to use this to use a different tool to watch for file changes on the file system. But of course, from an attacker point of view, you can abuse this to put a file there or a command that will do malicious stuff like backdoor your system, make a remote shell. And if you have this config in your Git folder and open it with VS Code will launch the Git utility, and Git will abide by this config and depending on the config, launch something. So basically, if a victim downloads and opens a malicious VS Code project or folder from a zip file, let's say, and opens it in VS Code, then we were able to execute arbitrary commands because of this Git configuration thing.
I got you. So the malicious file would be a malicious VS Code project. Is that true?
It doesn't have to be a VS Code project yet. It just has to be a folder that has this .git folder with a malicious config in it.
I gotcha. Okay. So the maliciousness is in the config. You just get a developer to load your malicious Git config. Is that correct?
Exactly. And the same thing doesn't only work in VS Code. We also found shell integrations, like if you have Fish or ZSH and you have a nice integration that shows which Git branch you're on right now. So if you cd into a malicious directory, the same thing happens. The command gets executed.
Yeah, I just want to, in my experience using this integration with, I like the JetBrains tools, as I said. It's very handy for a developer, by the way, especially like you said, when you have multiple developers in a fairly large project. Having the Git integration in your IDE, oftentimes as a use case, I'd find myself talking to one of the other developers and they go, oh, I have a fix for that, or something you should look at in this branch. And then I would go in my IDE, I would diff that branch with my local branch and just like manually do a merge for like a small feature, which is obviously not the best way to do it, but I did some of that as well. And it's super useful. So, preying upon these features that are really useful to developers is kind of scary.
Yeah, and in the case of VS Code, it's enabled by default. It's a built-in extension. It's part of the workflow, and like it's expected from you to use it in general. Microsoft just acquired GitHub some time ago, so they were not going to remove this Git integration at all. So they kind of tried to patch it and hide it. So there is this Workspace Trust thing. When you open a new project in VS Code, it asks you to trust it folder, and if you say yes, you're likely going to get owned. And if you say no, less extension and less integration will run. But we've still found a few other bugs to get around this trust thing.
Yeah. Aaron, did you have any questions up to this point? Sorry, I can't
did you see?
On the screen.
No, it's okay. Did you see me scribbling away?
Yeah.
No,
I did not,
no. Oh,
but,
yeah. No, that's great. I'm just wondering, guys. I have a sort of hopefully a complete question in 3 parts. How do you harness what you've discovered? Can you find anything can you find anything in the wild that's been pwned by these vulnerabilities? And then finally, after that, can you retrospectively look at the software written by the hacked VS Code instances and follow a supply chain from there?
So we don't do threat analysis. It's not part of a job, and we don't have like the right tools, and like we're not a threat analysis company, so we never really tried to see if it was exploited in the wild. But we know that at some point somebody was sending vulnerability researchers and developers on Twitter that were sending them Visual Studio projects. And if you would take this Visual Studio project, you would build it because somebody was asking for help and you were somebody nice and you would really wanted to help. You would build it and you would get compromised. And I think it's Google TAC that first reported it, and it was North Korea. So definitely people try to use this kind of dangerous features to exploit to compromise people. I'm not aware of any in-the-wild exploit for VS Code, but I think it definitely shows that it's definitely possible, and it's not the only bug that we found. I think it's more, it's a general problem, and it's likely gonna happen again. We're likely gonna see a new CV for Visual Studio Code, and hopefully it's never gonna get exploited. But I mean, it's been sensible. It's been things that people tend to use to try to compromise researchers and developers.
Do you think people actually using VS Code now, do they physically need to worry about what's happening and these vulnerabilities?
I think it's like in my case, if I can maybe in my case, it's my job to look at source code that comes from online that I don't trust. Like I cannot trust random people on GitHub, so I have to git clone random repositories on my laptop and open it in VS Code to edit it. It's part of my job. And when you're a developer, you likely do the same with every single dependency that you use, and it's really part of everybody's workflow. And you don't expect that like reading text files would create vulnerabilities. it doesn't seem like a big issue in the first place. So I guess people should really like keep VSCode up to date and to try to avoid these vulnerabilities from being exploited. Hopefully there is an auto-update process in VSCode, so it's just easier. But nowadays when I work with external source code, I work in a VM. Even with what Paul mentioned, if you CD into the wrong directory, when we have shell integration, it's also unsafe. So honestly, I just stopped trusting all this third-party texts, and I just do it in a VM now.
Yeah, it's interesting that your IDE has to interact with other binaries, and I think the main problem that you're pointing out, a class of vulnerabilities, is argument injection, right? With that integration of something like VS Code with other utilities that are on your system. Is that correct?
So we yeah, go on, Paul.
Yeah, so basically we found different things. So what I was explaining earlier, it wasn't a argument injection in itself. It's basically this untrusted configuration that is being used. But we also found argument injections and maybe command injections. So it's all around the same thing. Like you said, if you interface with external binaries, then there's things that can go wrong. Either things that the binary itself does, what the developer of the IDE doesn't know or expect the binary to do, or directly when calling the binary, you could have argument or command injections.
Yeah, and what Paul mentioned for Git, so the argument injection and the unsafe local configuration file, like 2 months ago, we found the exact same bug. So this argument injection and this local unsafe configuration file in the NPM extension, and the exact same bugs, like same root cause, same everything, same impacts in remote code execution if you open the wrong folder. And it was also scary because it triggers when you open a specific file, which is package.json. If you open this file, you type a few things, it triggers bugs, even if you didn't trust Workspace. That means that even if you're running with the safest configuration of VS Code, you can get exploited in this case. So it's also a bit scary, and it's definitely a recurring pattern to have this kind of specific bugs for VS Code.
Oh, so yeah, I guess we should probably talk. Did you both present at, was it DEF CON or Black Hat or both?
Yeah, DEF CON.
DEF CON.
Okay, so you both presented at DEF CON, but then you found you had more vulnerabilities, but you couldn't talk about them when you presented at DEF CON. Is that true?
Yeah. It's always the same thing. While preparing for a talk, for a blog post, for anything, you look again even more exact at the source code you were looking at to prepare it for the slides. And then you think about, wait a minute, this line, I never looked at it. This looks also fishy. And then you more often than not, find something else that you then report and can't have in that talk, but in a later edition.
Yeah, in this case, it was a bypass of a bypass of a bypass. So it's like this code has been looked a lot, and we've also looked a lot at these lines when preparing everything, and there was still something.
So what was I guess give our audience the delineation between what was new that you haven't talked about at DEF CON?
What we found in the meantime was, like Thomas said, in the NPM extension. It's basically the same. One of them was that you could have a local config file. I think it's called .npmrc. And it's pretty similar to the .git/config file, just for the NPM package manager. And you can configure some options, and some of them, or at least one of them, allowed us to execute arbitrary commands. I think it was a little bit limited to the versions of NPM, but we also don't develop fully weaponized exploits, right? We're only here to have a proof of concept to show that in at least some configurations it's vulnerable and exploitable, and then we report it as soon as we can. So and the other thing was, I think, an argument injection, also in the same way, where when the npm command was called, you could set some arguments. I don't remember the specifics of the one. Thomas, do you remember?
Yeah, it's like the two were really closely related. We could inject an argument that tells npm to load an arbitrary configuration file from the same folder, and then it's just kind of the same process from here. We just define a malicious configuration, and we execute arbitrary commands. And yeah, it was also we were a bit limited by the NPM versions because this configuration they used to allow a lot of unsafe things, and now they try to like make it a bit safer. But I think we did a POC on the latest Ubuntu LTS, and it worked at the time. But on the most recent version of NPMs, we couldn't prove it. That doesn't mean it's not possible. That just means we didn't look enough, I guess.
Yeah, no, I get you. But this is all integrations and extensions from the IDE, because most developers, right, not only are integrated with Git, but you're also integrated maybe with Docker and also with the languages and packages that are associated with that language, right? In other words, like when I was in Python, the IDE, I could configure which was my Python interpreter, which virtual env that I wanted to point at, and all of that was integrated into the IDE. And with VS Code, it's the same thing for NPM, right? The IDE is kind of taking care of the background where your packages are loaded and built and all that stuff and configured.
Yeah, it's called extension, but actually it's like it's built in. It's shipped with VS Code, and when you start with VS Code, it's enabled by default. And I think I'm not sure, but I think you can't even disable it. Like you have to live with it, which is not a good thing when you have security bugs in it, I guess. But it's fixed now.
Yeah, well, it's good that it's fixed. Aaron, sorry, did you have more questions? It's hard because I can't see Aaron. Normally I can.
No, it's okay. I can shout out. But when you have sort of like I guess multifaceted question about Microsoft, what was the experience like reporting these vulnerabilities to Microsoft? Were there any sort of challenges during the process? And what sort of advice from your perspective would you give to the creators of IDEs to make their software more secure?
So for the first one, the reporting to Microsoft part, we had a pretty good experience, even a funny one in some sort. So for the very first vulnerability, I think it was the Git local configuration thing, we got a $30,000 bug bounty, which was pretty nice, and we didn't even expect it. So we asked them, "Hey, thanks for the bounty. We really appreciate it. Why did we get so much? Do you have any cloud-hosted version of VS Code in Azure or anything like this? So if we would know, then we could maybe look more into this or whatever." And they never really got back to us, and we were like, okay, we'll take the money anyways, and we donated it to charity, which was even more cool. And then the year after, we found
Paul, I want to stop you right there. So Microsoft said you get $30,000 for reporting this bug, and you both graciously said we're going to donate to charity. What went into that decision to donate to charity, which I think is an amazing thing, by the way?
Yeah, I do too.
Yeah, so basically at some point in our research team, we were like, okay, what do we do if we get bounties? Usually we look at open source projects, so bounties are not as likely as if you would at a company's product.
Sure.
So we said, okay, what's the incentives we want to have, and how can we deal with this without getting, greedy or jealous of others? So basically what we came up with is we make a list of like charities, known charities, and whoever gets a bounty for their research can decide to which charity it should be donated, but we will basically give it to charity to not have any sort of other clashes, and I think this worked pretty well. Yeah.
Nice. Which charity did this particular bounty go towards?
We split it up, so I don't know if I remember them all. So this was in 2021. One was, I think, called Sustainable Bolivia. They're doing some sustainability work in Bolivia, and we had a team member who, before joining Sonar, traveled around the world a bit until COVID hit, and then I think they knew somebody from that charity, so he definitely knew that the majority of the money would go to the cause and not to advertisements and marketing stuff. So we try to select those kinds of charities, and I think we also had one that does medical operations for children that got hit by grenades or in war zones and stuff like this. So I think those were at least two of them. Yeah.
Good for you. Oh, so now we're at the point in the story where Microsoft awarded the bounty, but then what happened, right? There was was it a mistake? Is that the way I understood it?
Yeah, so later we found out that it actually was a mistake. So 1 year after that initial vulnerability, we found another one, which was a argument injection in what's called I think, protocol handler. So if you, let's say, on GitLab, you have a button, open this project in VSCode. And if you click the button, then the browser will try to open a link with the VSCode protocol, which is then handled by VSCode if you have it installed. And VS Code will ask you, hey, you click this button somewhere else. This will clone this repo from this URL to your machine. Do you want to do it? And if you click yes, then there was an argument injection. So if the repo URL started with -- then it would be interpreted in the word is tricky, interpreted as a argument. So you could tell Git basically to, again, execute commands via a special command line flag. So this was a pretty similar impact, right? Kind of remote code execution if you trick a victim to visit your website. And yeah, you get arbitrary code execution on their machine. So we again reported it, and we thought we would get a similar bounty if there was something at Microsoft that uses VS Code in a way that's really sensitive and worth this much money. So we reported it again. They fixed it and everything, but then when it came to the bounty part, they basically said, last time we gave you this big bounty, but actually that was a mistake, because all VS Code extensions, including the built-in ones and that are shipped with VS Code, are not in scope of their bug bounty program. So basically, because it was in the internal Git extension, but it's, as I said, shipped and built in, it was still considered an extension and out of scope. So we didn't get any bounty for that one.
That's really funny. But I mean, Microsoft, as you said, was nice to, the bug bounty kind of mistake aside, Microsoft was great to work in terms of reporting and disclosure, it sounds like.
At least in our experience, it all went pretty smoothly. We didn't have too long delays, and they fixed everything. So it went pretty nice. I heard different things from others, but at least in our personal experience, we can't really complain.
Yeah.
And
that's good. Go ahead, Thomas. Go ahead.
We have this 90-day disclosure policy. So after 90 days, we would have said, you need to really fix it, because we'll just disclose details for everybody to just protect themselves. And we never had to complain about anything. They were like really on time every time. The patch was looking good. The release is quite efficient. So I think not much to complain about with Microsoft in this case.
Yeah, and that's good to hear. We were talking with, I believe it was Jared DeMott, who I believe works for MSRC. There's lots of different divisions at Microsoft, right? And we were talking about how, in general, most people have a positive experience with bug bounty programs, even in general, and bug bounty programs with Microsoft, and that sometimes there are disputes, but those are the exceptions, not the rule. So you both are kind of a testament that, for the most part, the process works, and there's no drama, as it were, which is good, because that means the vulnerabilities get fixed, and we can all live in a slightly safer place, at least for some time, until you both find the next vulnerability in VS Code.
Yeah, and I think we also depend on like the bad reputation of this MSRC bug bounties. So because maybe a lot of people also leave thanks to it. Like there are a lot of full-time bug hunters on Microsoft products, and they just make their living out of these bugs. And I think when you have to wait for 6 months, or when it's getting closed as informative or like duplicate for no reason, and you get like no proper communication channel with the triagers and Microsoft, it may be a bit stressful if you kind of like tight on money. So I think it's like in our case, I would say we're not doing it for the money. We're not getting money for this thing anyway, except when they make mistakes. But definitely we can also afford to. It's fine. Like if they don't reply on the same day, if it gets closed as duplicate, we don't. It doesn't matter for us. It's fine. But yeah, if it's your source of income, you may have like strong expectations when it comes to this bug bounty program.
In terms of keeping your IDE up to date, I can, a little bit of my experience, the JetBrains tools would complain pretty loudly if it was out of date, and it seemed like there was a steady stream of software updates for that process. Of course, as we all know, on the show and listening, applying an update means there is a potential to break something, and that would happen. I would, install the latest version. It would break something in one of my projects or configurations, and I'd have to go, dig and fix it, which would take away from my development time. So what's your advice for folks to cleanly keep their VS Code IDEs up to date?
I think it's a background process. Like basically, I get a prompt also every once in a while that tells me to upgrade, and I also run the nightly version, which I would not advise. Like if you have a strong dependency with your IDE versions and numbers, you should maybe go on stable. But I like to update often for VS Code, and also I see when my things get patched. But I think I would say it's in the end of the vendors in practice. Like if you silently patch everything, users are never gonna upgrade, and they're gonna get compromised, and it's gonna get exploited, and it's not a good thing. So I really think it's up to the vendors to say, okay, this is a security risk, and you should upgrade, or we will upgrade for you. It's even better. And also, they should maybe refrain from trying to hide and say, oh yeah, it's just a bug fix release, when in fact it's a security release. I also think it would maybe be easier for users to know when to update absolutely, like right now, or when they can delay it for a few weeks.
Now, all the bugs that you folks found, they did get CVEs assigned to them, correct?
Yeah.
Yeah, that's good. I mean, we've kind of been having this discussion about CVE, but in this case, it also sounds like the CVE process went well as well, because that, to your point, Tomas, I hate it when software updates and it goes, oh, this is just an update. It doesn't tell me that, it fixes some kind of security vulnerability. CVE is meant to be like one of those tracking mechanisms, right? To say this CVE was addressed in this update, so we as defenders can make better risk decisions. So.
Yeah, I think it's also one of the good things with Microsoft. There are CNA, so they can already assign CV numbers. They don't have to wait for MIT or some other CNA to assign it. It's just like much faster in the process, and they have this release every Tuesday or every other Tuesday of patches. So like people can expect security updates from Microsoft every other Tuesday, and it's easier for system admins and even like security conscious people to be ready to upgrade. So it was like, really efficient with this.
Nice. Well, that's good. So do you guys still run Visual Code Studio, right? And you're just making sure it's kept up to date, basically, is the advice here. Is there any other configuration that you would recommend to further secure the IDE?
I would say if you want to improve it for security, you should use as little extensions as possible. As we said, I think some of them can't be really disabled. But of course, I think one of the strengths of the VS Code ecosystem is the big plugin market, where you can get a lot of extensions that do really helpful stuff. But of course, that also increases the attack surface of your IDE, right? If you have more functionality, more extensions, parsing files, trying to highlight stuff, trying to show stuff. Even, if you have the Workspace Trust thing, sometimes the extensions still run even in untrusted workspaces, and you have to kind of trust the third-party developer to have this set right, that they know that this Workspace Trust thing exists and they know what they're doing if it runs in untrusted workspaces. So if you want to be super secure, use as little as extensions as possible. But of course, that will also decrease your productivity, and you have to kind of find the balance between that. And I think, this is also something that could in general be done by security researchers or by Microsoft themselves to start to look into the third-party extensions. We also found two things in third-party extensions. And those were only ones of the top ones, but there's so many that there must be a lot of them out there that also have some vulnerabilities in them.
And this weekend I was talking about this bug with somebody like a security researcher, and he told me he was running VS Code in user namespace. So he's running Linux, so he's just running unshare to remove network access and some like file system access from VS Code. And it's I think just like easy way to make it a bit safer. It won't prevent everything, but it's still much, much better.
Yeah, no, I agree. I've seen recently some advancements in Linux, right? I think it was Ubuntu that was like, oh, we're going to run your browsers now by default in our next release inside of AppArmor containers, right? So there are technologies like SecComp and others in Linux where you can containerize that. I also think Windows has a similar architecture you could take advantage of too.
Yeah, I think it only needs to be like a default thing. Like you shouldn't see it. You shouldn't like even if you don't know about it, you shouldn't see it. Like should not refrain you from doing anything. But if it brings a bit more security, it would be awesome. Yeah.
Yeah, because you do rely on some of the third-party plugins. Like Paul, you were saying that enhance your productivity. One of those for me is I have to edit in VI or Vim, right? Like it's just muscle memory how I edit. So when I use VS Code or any other IDE, I typically the first thing I do is I go find a plugin that allows me to use VI emulation, basically. But you have to trust the supply chain, not just the VS Code, but of these plugins as well. Are you guys aware of any advancements in tightening down the supply chain with specifics to VS Code?
Not specifically to VS Code. I think there it's just the big JavaScript and NPM ecosystem, because the plugins and VS Code itself is mainly written in TypeScript, so basically JavaScript. But because we were also looking at package managers in the past, like Thomas' Composer bug, we know that there's some advancements in that direction. I forgot the name of the service. Thomas, do you remember the service?
It's called SigStore.
Yeah, SigStore. Yeah.
Yeah. So in general, in the supply chain and dependency world, there are advancements to have some signing, but of course, specific approaches only can take out specific attack surfaces. So I think for SigStore, if they sign all the dependencies, then you at least know that you get the stuff that the original developer wrote. But if that developer gets compromised and they put in malware and sign it, then you're still screwed.
Yeah, but that was the original intent, right? That's good.
Yeah.
And we get in this weird dependency thing too, where developers, I mean, my example was more productivity related, but I'd imagine that for your product at Sonar and many others, right, have that IDE integration where it's basically linting for security and doing static analysis as you code. Is that how your product? Not ask your product specific question, right? But is that in general how a lot of these products work?
Yeah. So exactly. These products all attach in your IDE. Hopefully, that's the best way to tackle security problems or code problems is when it's being written, right, before it goes somewhere else. So yeah, if you want to look at supply chain attacks, then you definitely have one more piece of software in your IDE, essentially on your machine, that uses stuff that you would have to know if it's secure or not. But as we all know by now, all of the supply chains of software have gotten too big for the end user to check it all.
Yeah, no, I agree. Yeah, you get into transient dependencies, right? Dependencies of dependencies. And then it's just tough to know, like with the plugin ecosystem in VS Code as an example, it's tough to know whether a developer has done something malicious or if a malicious actor has taken over the project. How does that factor into a reputation score? Because there's all that stuff happening well upstream beyond the developer's insights.
Yeah, and I think, for example, the VS Code Marketplace is also an example of you don't really know if something is secure or not. I think they have like these verified developers, but it only means that you verified the domain that's attached to the developer's profile. And in general, on the VS Code Marketplace, you can just everybody can just release something. For example, for one of the vulnerabilities that we found, where it was in GitHub's PR and issues extension. So if you don't want to jump to github.com to look at PRs and issues, you want to do it in your IDE. There's a plugin for that. And then there was a view where you see the body and the title of a PR, and they render it in Markdown like they do on github.com. But the thing for VS Code is that a lot of the UI in general is Markdown, and they have a special mode for this Markdown where you can say it's trusted. And this allows them to have special links that can, if you click them, execute VS Code internal commands. So not OS commands, but for example, the command that would say, open the code view or open the extensions view, or the command that says, install this specific extension. So when I wrote the proof of concept exploit, I basically uploaded a proof of concept extension to the VS Code extension store that doesn't do anything malicious. It just spawns a calculator as the classic way of showing arbitrary code execution. And when you install it, it just pops a calc. But of course, I could have put any command in there, and then the exploit just triggers the VS Code command that installs this extension. So I think in general, I'm not aware of if or how much work Microsoft is doing in securing the store and scanning for malware and everything like that. But at least I could upload my proof of concept and it was immediately available and I could just use it.
Yeah, that's actually kind of scary. I think I've seen that before. Did you guys publish research on that?
We didn't publish a blog post yet, but we had it in our DevCon talk.
Yeah, okay. No, that's pretty awesome. Aaron, any other questions from you?
I'm wondering if the guys have looked at any cloud-based environments, and is there any unique challenges compared to local IDEs?
So I didn't personally looked into it, but there's this cloud version of VS Code, and there is a GitHub Workspace thing, which is also based on VS Code, and I think it's also brings some interesting things, because if you get an XSS, you can sometimes leak secrets attached to your GitHub repo and maybe push some code changes and stuff. And I remember that 2 years ago or 3 years ago, there were a DevCon talk on, I think it was called warming through cloud-based IDEs, and this person exactly did this thing. So he would create files that if you would render a new cloud-based IDE, would leak some secrets and would infect source code, and you could do it for many cloud-based IDEs. It was pretty cool. I can try to find the link and send to you.
Yeah,
perfect.
That'd be awesome.
Just one final one. I'll try and more coherently ask the second part of my last question, if that's okay. What proactive steps should software companies take when developing the next generation of IDEs to ensure that they're secure from this by design from inception?
I think, in general, this Workspace Trust thing is a good first step that not only VS Code added. I think JetBrains IDEs also have this kind of thing where if you open a project, it asks you, hey, do you trust this project? So it's a first step. And yeah, as we've seen, integrating with third-party tools can be a treasure trove for bugs. So I guess developers should put more emphasis that these connections are safe and are not doing anything malicious. And yeah, as Thomas said, this small trick of running your IDE in a namespace, I think if IDE vendors really want to get into the security of the IDEs, they could look into actually sandboxing different parts of the IDE. So let's say if you don't really trust yourself as a vendor to make the connection to Git, to the Git command line executable really, really secure, because Git is just too complex, you could start to put it in a sandbox to have more layers of security. But yeah, the first step is probably to disable everything that could go wrong when you deal with untrusted projects.
Very good, thank you.
Thomas and Paul, anything else you're working on now that you want to talk about? Or I'm assuming if you've moved on to the next thing, you're not ready to talk about it yet, right?
Yeah, kind of. We're gonna release some new bugs. So we're gonna make a blog post, kind of gets back on what we did on our talk with different categories, different kind of attack surfaces that we found in VSCode that could be also applied to any other IDE. Actually, some of the bugs we found were also working in the JetBrains suite, and at the time we also reported it to GitHub Atom, which is end of life now, so they didn't fix it. And we're also going to release something mid-November on some bugs on third-party extension, and then later on the NPM bugs. So we're really going to kind of like wrap up this project in November, and we're already looking at some other new targets, but we can't really say anything yet. But we got pretty cool stuff in line so far.
I think we can spoil that we will be back on developer tooling in general. So maybe not IDEs, but other stuff that developers use, because developers seem to be a good target for cyber criminals because they have access to a lot of stuff. So we definitely want to look at all the source software that they use.
Fantastic. Well, thank you both for coming on the show today. Aaron, thank you very much for hosting with me. That will conclude this interview segment and also wrap up our show. So thanks everyone for listening and watching. We'll see you next time. Over and out.